Hi, we're the developers of Project Z, the smart natural light manipulation system. I'm the project manager, Oscar.
Hi, I'm Diego, the iOS developer.
Hi, I'm Alvin, the Android mobile developer.
I'm Pedro, the hardware developer.
Sleep deprivation is a serious issue. It can cause many negative and harmful effects upon an individual's life.
For example, sleep is correlated with earlier death, high risk of blood pressure, and more forgetfulness. Getting more sleep is something I've been obsessed over for the last 4 years. I used to go to class with only 4 hours of sleep. I realized that since I'm getting 4 hours of sleep a day, that's 28 hours of wakefulness that I'm less than optimal. So it's like 50% optimal. Whereas I could be getting 8 hours of sleep, but remain 100% awake. So I found that laying in bed isn't the greatest indicator of how good someone's sleep is. One thing I found that I had no control over was sunlight. For example, if you spend 8 hours in bed but only sleep for 6 hours, that's a 75% efficiency for sleep. The goal of this project is to try to push this efficiency to near 100% by strengthening your circadian rhythm. So the project is called Project Z. Why Z? Well, in sleep science, there's this term called Zeitgeber, which is external stimuli that affects one's circadian rhythm. We're going to help you maximize the effect light has on your circadian rhythm. When we go to sleep, everyone must face the choice of whether to turn the blinds on or whether to turn the blinds off. If the blinds are open, then the sunlight from the morning gets in and helps wake you up. However, if the blinds are closed, then the light from outside at night will be blocked, thus helping you fall asleep faster. So project overview is we have a smartphone. Right now our most developed platform is iOS. Our iOS will be able to send commands to the Arduino to move the blinds counterclockwise or clockwise. And then on the iOS we can also set a schedule for the Arduino motor to move at a certain time at a certain day.
Since we were planning to build a product that can communicate with the iOS and Android, we used the HM10 chip because iOS can only connect to the Bluetooth Low Energy. We have created a time library for the Arduino so it could keep track of the real time. We also built a data structure to store all the schedules set up by the user and also to store other important data such as the current position and the time. For the Wi-Fi implementation, we used the ESP8266 because it was inexpensive and it could provide all the features that we needed, such as the access point and server.
Okay, for the mobile development application, we intended to have the same functionality and feature as the iOS. So we decided to do the same thing what we do with iOS implements by implementing the Bluetooth functionality of low energy. So the Android app can communicate with the Arduino and control from there.
The device itself and the Arduino prototype keeps track of scheduling internally. Our goal was to be able to calibrate it and set the schedule by both Bluetooth Low Energy and Wi-Fi, such that the device could be accessible from the internet or from anywhere in the building.